There is a specific thrill in the forward momentum of a modern highway, the feeling that technology is finally catching up to our expectations. But that momentum usually hits a wall the moment you see the sticker price. A new electric vehicle typically costs $40,000 to $55,000, a steep premium that makes most buyers walk straight back to the gasoline section. Initially, the purchase gap is wide. Gasoline starts at $30,000, while electric demands $15,000 more. But the 10-year total tells a different story. Factoring in a decade of driving, electric settles at $68,000, $1,300 less than gasoline. This reversal is driven by mechanical physics. Electric motors possess a staggering efficiency advantage, allowing them to extract more movement from every dollar of energy. When you choose a vehicle, you are locking yourself into a 10-year operational contract. Mechanical superiority dictates the terms of that contract, determining exactly how much you will pay to keep those wheels turning. This assembly line highlights the extreme mechanical complexity of the internal combustion engine. To create movement, it relies on thousands of micro-explosions every minute. Those explosions generate intense heat, often reaching 2,500 degrees Celsius inside the engine block. This diagram shows the cost of that heat. Out of 100 units of energy in your fuel, up to 84% is instantly lost to waste heat. That leaves only 16 to 25% that actually reaches the wheels to move the car. Electric motors replace fire with electromagnetic fields, using current to create instant rotational motion. Because there is no combustion, the flow diagram shows a nearly direct path. Up to 91% of electricity goes straight to the wheels. This gap means gasoline users pay full price to mostly generate engine heat, while electricity buyers are paying for movement. Gas engines also face a physical limit. They produce zero torque at a standstill. They have to stay within a narrow RPM range just to keep from stalling. To bypass this, cars require heavy multi-gear transmissions, complex systems of clutches and fluids that are prone to failure as the miles add up. An electric motor produces its maximum pulling power the moment you touch the pedal. It can spin from 0 to 15,000 RPMs without needing to shift a single gear. Removing the transmission removes heavy exhaust systems, complex fuel pumps, and engine oil. The most expensive points of failure in a traditional car simply don't exist here. This ledger compares 10 years of maintenance. For a gas car, oil changes, spark plugs, and timing belts add up to roughly $8,500. The EV ledger is essentially tires and air filters, totaling only $2,500. The simplicity of an electric motor provides a smoother ride, while physically stripping thousands of dollars of mechanical liability out of your garage. Maintenance is only half the story. Gasoline prices are tethered to global crude markets, making them vulnerable to geopolitical shifts you cannot control. History shows that these global dependencies often lead to supply bottlenecks and localized rationing at the pump. Modern conflicts can double a monthly fuel budget in weeks, with oil prices swinging by over $100 a barrel in a single year. This constant price anxiety makes it nearly impossible for high-mileage commuters to accurately predict their long-term expenses. Electricity is generated locally and regulated regionally, which decouples your daily commute from the decisions of global oil cartels. By using off-peak home charging, you can effectively lock in fuel costs equivalent to $1.60 per gallon. Adopting electric energy provides a financial shield against global volatility, allowing you to accurately budget your life years in advance. Let's look at the final math for a household driving 15,000 miles every year. Moving from the gas pump to overnight home charging saves approximately $8,100 in energy costs over a decade. This chart shows the cumulative effect. Combining fuel savings with the $6,000 saved on maintenance, the net operational gain exceeds $14,000. Government tax incentives can pull the financial break-even point even closer, moving it from year 7 to year 3. If the upfront cost of a new car is still too high, the used EV market offers a unique path. These vehicles have already gone through their steepest period of depreciation. Buying used allows you to skip the premium price entirely, while immediately benefiting from the lower operating costs, beating the math of a used gas car from day one. This entire financial model depends on one specific factor: your daily access to a charging port. This chart plots who will actually see these savings. We have commute distance on the vertical axis and home charging access on the horizontal. For drivers with a driveway and a moderate commute, the 10-year ROI becomes a predictable outcome of the lower per man cost. However, the math changes significantly for urban apartment dwellers parking on the street. Relying entirely on public fast chargers, the cost per kilowatt hour often matches the cost of gasoline, removing the financial edge and adding hours of logistical friction to your week. Electric energy is the cheaper, more efficient choice for the vast majority of drivers. But if you don't have a place to plug in at night, the smartest financial move is an efficient hybrid until the local infrastructure catches up.